Hello everyone, hope you are all doing good. I'm very much excited to talk about artificial intelligence. So, I don't have to say the importance of artificial intelligence in today's world. Artificial intelligence is taking over the world. So, it is like now a mandatory thing to know and learn about artificial intelligence, especially with respect to your domain, like along with your domain. So, you could be a software developer, you could be a front end developer, you could be a network security engineer, you could be a network engineer, or you a cybersecurity specialist or whatever. But it's now like a mandatory thing to learn about artificial intelligence because it's really taking over the world at a very exponential rate. So let's get started. What is artificial intelligence? Artificial intelligence are nothing but the computer systems have become more advanced. Before it was like a general computer system. So what was a general computer system? So let's say you are working in your laptop or a desktop, then you're trying to use calculator app, and then you're trying to add 1 plus 1 on the day 1. So on the very first day you have performed this operation, you have got the output as 2. So in the day 2, say for example you have given 1 plus 2, it has now you've got the output 3, and day 3 1 plus 3 equal to 4. So now the computer got an understanding that, so right till now you give the output, it will give the output. Machine does not learn, like, so you give some work, the work will be done by the particular employee, then you get the output. But right now the computer system is able to understand whatever you're trying to do. So on day 4, what is the computer will think, because it's able to think on its own. Now you're going by the pattern, increasing, you're having a fixed input x as like fixed, and you're modifying the variable or incrementing the y variable one by one. Say 4 on the next day, like 5. So on the day 5, without even like thinking, without even you are going to input the variables x and y. Say for example, one is x and a fixed variable, and 1 2 3 4 in the right side is going to be y variable. It's like it's changing. So x is constant, y is variable. So day 5 it will give you the output 1 plus 5 equal to 6, even without you're going to give an input. That's how it has adapted. The artificial systems or the artificial intelligence computer system has adapted to learn on its own and then give the output. So that is going to be the uh, that is going to be the that is going to be the learning and adaptation. Problem solving involves, like, in real life or real life use case, such as um, artificial intelligence are able to now compete with like grandmasters in playing chesses and playing chess games, and then able to beat them. So that's how it has like cognitive ability to think on its own and beat the great experts from their respective domain. And in the pattern recognition, I told you, so you saw the pattern with respect to an example which I showed. But apart from that, it now able to predict the big market, like big market in the sense stock market, and even able to predict our weather forecast. So those things are like coming under the pattern recognitions. And human like processing now, like it's so much easy to like extract text, or like extract video, or like communicate. So that's how, like, the artificial intelligence have become more powerful in today's world. So why does it say human like processing? Because what is the difference between animals and humans? Animals cannot talk, they cannot communicate. Maybe they can communicate on their own language, because we don't think like they can communicate. They must be having. But overall, with respect to human level understanding, we communicate with own languages, because animals have a monotonous or a mono sounds or noises. But whereas we have different languages, we have different text, we have different subcategories. So now there are different text, like computer can understand different speeches, computer can understand different image, different videos. All these can be understood, it can be processed by the artificial intelligence computer systems. So that's how the artificial intelligence have become powerful. And so just given for an example, say for example this particular uh, presentation, you can see on the left side I've given a little bit an extended version, and in the right hand side I've given a small summarized version. So what does it do? It can mimic human behavior because it's able to adapt on its own. It can communicate. It can process on its own. It can learn and adapt, which we saw, and then solve problems, recognize the patterns, one, two, three, and go like that. Process information, and all these things we are able to do it with the help of artificial intelligence on its own. We are just going to give the input, it is going to process and give the output, and then we are going to proceed with the ongoing tasks. Just to give a example, one more example, say for example, like initially you will be having a computer system, you are giving a input, the CPU is going to process, and then it will give the output. It's the same logic with respect to artificial intelligence systems also, but the use case, the models varies, depends according to your need. So that's the understanding you should know with respect to artificial intelligence. So now we saw the introduction with respect to artificial intelligence. Now, like, let's move further in understanding, like, who were and all like responsible. I personally feel that we should know them. So let's get started with respect to the people who you should be knowing, like as an important thing, in like who are like founders of this artificial intelligence. So Mr. John McCarthy, he was the first person who termed the name artificial intelligence. He termed around 1955. So he was the first person to term to coin the terminology artificial intelligence. So he was working in his, in the tech lab. So with respect to handling the neuron models. So at that point of time, he coined the term uh, artificial intelligence. Mr. Frank Rosenblatt is the first person who given us a model to process a particular data or a requirement. So Mr. Frank Rosenfeld was the first person to build the model to process with respect to artificial intelligence. What was that model? I think it's behind this behind this image. You can see the perceptron. That was the first model which was developed in AI/ML. What does it do? It is a linear model. So anyway, like at the start, it should be like simple in the sense because the foundation is like something big. From the foundation only you try to build more complex algorithm models and everything. But so definitely I found these three people are very much important in artificial intelligence. Uh, the timeline. So now let's move to Jeffrey Hinton. He is from Google. Actually, he warned us that artificial intelligence have become more powerful. So it is even said like it's better to have a plumber job than a IN job. So that's how the artificial intelligence is becoming. But right now, I don't think like it's going to happen at a very fast rate. It will take some time, but it's going at a faster rate. But unless like you are trained with the AI and ML concepts and then you associate with your domain, you can survive for some time. So what does he handle or what does he do? He is called the current godfather of AI, the present or the contemporary uh, godfather of AI, because he he was the expert in developing deep learning and natural language processing. So Deep learning is something like you're going to use CNN, RNN, and everything, which we will be covering in future. CNN is nothing but convolutional neural networks, and R is like uh, relational neural networks. So these are all like are used in real life use case scenario. For example, CNN is used in like automatic car driving. So that is the principle used in artificial intelligence concept used by the self-driving car. So you no longer need drivers. So that convolutional neural networks is the principle behind the automatic or the self-driven cars. Now let's move into the evolution of artificial intelligence. So when does it start? So it goes date back to 1943, where the first McCulloch-Pitts neuron model was invented. So they developed a neuron model similar to uh, the brain, and so they started working on it, and then it's got slowly evolved. And in 1949, Ebbian learning created pathways for this neural model, and then it goes to Minsky-Edmonds neural network computer, the very first prototype like network model computer. And then in 1950s they went or proposed with the Alan Turing. I think you must be heard about Alan Turing, who first decoded the Enigma in the World War II. So he was responsible for that. You must be heard about Turing test, and then they decoded the encrypted images using the Turing. If you have seen imitation movie, you will be able to see the fantastic encryption and decryption concept of Enigma in the World War. So if time permits, just see that movie. And then in 1956, at Dartmouth conference coins artificial intelligence, which I told earlier. Like I think I told 1955. I think it's 1956. So in 1956, John McCarthy coined the term artificial intelligence at Dartmouth conference. So then in 1986, the neural networks is like further developed, and in 2001 came the evolution of data science, big data and data science. Those are like a whole different concept altogether. But right now, more often, like we will be associating artificial intelligence concept only with respect to cybersecurity, because these are all like ocean. Each model, each algorithm is like requires a PhD level knowledge to understand. But right now, like say for example, how can I say, like you know simple interest formula, right? So simple interest is equal to P into N into R divided by 100, which means like principal number of years rate of interest divided by the percentage formula. So that's how we calculate the simple interest. That's how you have to think like in each algorithm function, or like you just remember this formula. If you want to learn this formula, like how it obtained it, you have to learn from the all the theoretical concepts, or like yeah, you have to go through everything. But just as a fact, you remember this formula. In same way, we have different algorithms, different models being used for different use cases. You have to think about and use it. Generally, like how does you use artificial intelligence in today's world? So you see, you are having your system, you have your use case. Let's say my use case is finding a spam email, because that's how I relate a use case with respect to artificial intelligence in cybersecurity. So there is a mission. In your mission you have a Outlook app. In that Outlook app, you are going to get a email. Let's say you have two kinds of email. That is legitimate email, which is going to be called as benign, and you have a spam email, which is going to be unwanted thing coming inside your network. So you are going to So both these emails are coming to your Outlook app, to your system. But how do you differentiate this benign email and spam email? That's your logic to build the artificial intelligence, or that's the use case concept you have to build with respect to cybersecurity, using artificial intelligence to categorize that emails. So that's how your thinking should be. I hope you got it. So in that way, you are say now, generally, if you want to use artificial intelligence, the mandatory thing which you have to do is Python, which we will cover in the later classes. But as of now, you should know what is Python, and then by using Python code only, you are going to feed these data to the system, and then you will be processing, and then you will be getting the output. The general workflow would be, you are having a system, you are feeding the system with an input data. Your input data is benign and spam emails. Not like you're feeding the spam email and the benign email in the system. You are giving a scoring function or a scoring value to the Python code by giving a input. So initially when we discussed, we spoke about 1 plus 1 gives 2. 1 plus 2 gives 3 on day 1 and day 2, day 3 respectively. We are having 1 as a constant, and your 1, 2, 3 in the right side, it's variable. Just like that, your benign email, your spam email is coming to your Outlook. You are giving a scoring value to that benign email and spam email. Say for example, that scoring value is, for benign you are giving +1, and for spam you are giving -1. So now you are having 5 emails or 10 emails coming. Say you are having 10 emails incoming. So you are going to differentiate or segregate between which is benign email, which is spam email. So in that, you have given a scoring value to each email. So if 5 emails are benign, it's going to be 1 1 1 1 in each sequence series, and then in the if the spam emails are received, it's going to be -1 -1 and -1. So you need to understand the concepts of the arithmetic series, vector algebra, and probability. I know you guys are thinking that, when did I use this earlier? So you are always thinking that, why did I study algebra? Why did I study probability? Why did I study vector algebra? Where I'm going to use, or where did I use till now in my real life example? Trust me, guys, you're going to use in artificial intelligence. So, so that's how you need to understand the flow. So this is a very basic example. I will be explaining overview example for each model. Overview example, not in-depth example, because in-depth example will take years PhD level expertise to explain the things. But generally you need to understand this flow. This is the basic flow. Let me cover further, but I think I stopped in between. Let me go back to the evolution of artificial intelligence. So till now we stopped with big data and science, and now in 2011 we went with deep learning. Deep learning we discussed earlier, like CNN, RNN. CNN, the convolutional neural networks used in the self-driving cars, and in 2021 we have the generative AI and LLMs. Generative AI, what is AI and generative AI? Artificial intelligence, say for example, is a complete solar system. or universe, whatever you say. Although there is a difference between universe and solar system, I would say like it's a universe. Okay, artificial intelligence is a universe. In that, machine learning is a very powerful subset technique of the artificial intelligence to perform our complex tasks. Okay, and in that machine learning, you have several other algorithms or models to perform our function or like our use case. So you need to understand your requirement and use the best optimal uh, algorithm or model to perform the task and get the output. So say for example like you are having, say now you are staying in a house, you are having a very little small road path, you are staying in your house, you are having a little small roadway path, and you have a car and you have a two-wheeler. Okay, let's consider this two-wheeler. Okay, you have a car, you have a two-wheeler. In this small path, which is like much appreciable or like which will be like most suited to use in this roadway path, because you cannot get your car inside this small roadway path to your home. So either you park your car somewhere else in a public space or a rented space, and you use your two-wheeler to go in this small roadway path. Similarly, with your respect to your requirement, you have to use your own model and then get the exact output. So generally, you're feeding your system, because there are like n number of models. There are like several models: linear models, supervised learning, unsupervised learning. You need to, for that particular complex task, which will be my ideal learning, to process this particular task and get the output with much accuracy. So generally what will be, you will be feeding your input, your LLM will be processing the tasks, it will be giving you the output. But you need to train and test your input variables. You have to train and test your input variables and get the output with utmost accuracy, which is like giving you the utmost accuracy you have to find out. That's the thing. So you have several models, you give your output, your LLM process that particular complex tasks, it will give you the output, and then from the output you plot the data. Say in supervised learning technique, we will cover like what is supervised learning technique, what is linear learning, what is unsupervised learning, what is generative AI in upcoming thing. But just to give an overview, you have linear model, you have unsupervised learning or supervised learning, you have supervised learning, unsupervised learning. So you have given input to your LLM model, it has given an output by using, first for example you have using linear model in the first operation, and you are plotting the data from the x and y inputs, because you are giving the inputs as an x and y variable most often in the artificial intelligence. So similarly in supervised learning also, you are going to give the input with the labeled data, and you are going to plot that particular operation, and then in unsupervised learning also you are going to plot the data. With all these graphical representation, you get an output value, which is the highest percentage value you are going to get, is the optimal solution which you can use for your artificial intelligence task. I hope you get it In the upcoming slides, we will be covering further, but this is just want to give an insight like what it is, what is your LLM, how it is considering the inputs and how it process and so on. Okay.